Okay, so a few of you have been asking questions. I want to first answer it, make a few notes, but I'm going to also send these notes on Piazza. So if you haven't completed Lab 0 during lab, you can complete that lab any point in time, but you must get checked off. So there are office hours today, right after class, starting from 4 till 8. You can go to any office hours, seek help. There are office hours tomorrow, and you can finish Lab 0 at any point in time. Starting with future labs, you have to finish in time, but Lab 0 you can finish anytime. If you have questions about anything, including labs, homeworks, we have no homeworks yet, don't ask me where the homework is, labs, homeworks, anything that you want. And please don't be shy to ask questions because we understand how much information you have to absorb and we really want to help you. But please don't email me. I am one person, whereas on Piazza I have 50 people watching you, right? In addition to all our mentors and TAs, we have all of you who can answer each other's questions. Please send all your questions to Piazza. Don't be ashamed that your question sounds too simple or anything like that. Please do post on Piazza. Okay? So Lab 0 you can complete anytime. We are still working on Lab 1 because Lab 1 requires us to set up something else, but it's almost done. You can expect that Lab 1 will be posted on Piazza tomorrow. This is like the little cam, right? So you can see. Okay, so I will send you a direct email from Piazza. So you will be immediately notified when Lab 1 is on. You can also check it. It will be under resources. So I've been already told that the textbook, by their mistake, has not been ordered. And if you are going to buy, but it is now ordered, so it should be in very soon. You are not required it. You're not required to use it. You can use the other textbook. But if you are going to get it on your own, make sure that you get edition 1. Was that edition 1? Who told me about this? Yes, edition 1? Yes. Edition 2 is in Python 3 we don't want, right? So textbook, get version 1. And I'm going to post all of these to Piazza, so you will learn that I am going to give you information that you need. Lab sections, I know that some of you had exceptions for just this week alone and asked me permission, which is perfectly fine. But in general, you must always attend your own section. Do not attend some other section. Because as you know, seats are limited, our staff is limited, so we cannot really do more. So please attend your own section. I have looked through the survey. Some sections are a little bit too full, so if only 10 of you I'm going to ask to move to a different section, you can refuse, but you are going to get an email directly from me if that were to happen. But outside, please attend your own section. So you have, does everybody have one of these? Right? If not, I don't know how to get those here. I'm going to send some this way. So I'm going to send this way. Look behind you and then this way. So this is course notes. This is the same exact material that we have on the course website. And I will bring to class copies like this so you can write on them. However, I got into trouble by printing these in color last year because I was told that we are a poor department, so we cannot afford color copies. Um, so if you want the color copies yourself, you can print these. I have started putting these on Piazza. So you can find these in PDF, in color, under resources, and right here. So you can find this material right here. Nope, that's not it. It's in here somewhere. There we go. Okay. And the coloring kind of helps with the syntax coloring, right? So if you do want it, if you want to take notes on PDF, you can do that electronically. If you want hard copy, you can print it. Or if you're okay with the ones I bring, take it. And look, depending on how many are being used, I'm going to reduce the copies I make, because as you know, there's a huge number I have to carry every week. Okay. Many thanks to everybody who filled the survey. I really appreciate it. I cannot really move everybody because it's really difficult. So I'm going to start with moving a few of you just to balance some sections. And if you're having a trouble with your section, you can ask me to change, but please, try your section for a few weeks, and then if you have a good excuse, I'm happy to accommodate you. So if you're wondering which percentage of the class has no programming experience, it was in fact 45%. And this is exactly the same last fall. So in the spring it's generally 50, in the fall it's 45%. So, okay. With all that, I'm going to start talking about actually programming stuff. Do you have any questions for me? Now, you are welcome to ask questions during... Yeah, this week. Okay. So remember, you are welcome to ask questions any point in time in the lecture, but also think about questions that will help the whole class, right? Everybody's trying to learn and pay attention. So if you're going to ask questions, make sure that that's not a very, side topic. It's the topic that we are actually discussing right now so that it can help everybody. Okay. All right, so this is what the course notes are going to look like. You have the same material online. When I mean online, I mean this. Okay, let me clean that. Okay. So that you don't see all the mails I get. So all the course notes are the same exact ones that I have online here. Right? So this is the same material. Okay. So today we are going to talk about numbers and basic operations and variables and operator precedence. So this is kind of the very basic stuff that you may or may not have seen. But beware that Python does some things differently than other languages, so there's always a little variation in this. And make sure that you take lots of notes on these. This is for you so that you can actually write whatever we are doing. And I'll try to stop at certain points to give you time to practice certain things. You can practice them on paper or on pencil, or you can practice them on your computer. Both are fine. You will find that there are two separate ways to solve things. You're going to do a lot on computer, but you also need to do a lot on paper and pencil, so that both are fine ways of doing things. Okay? You will catch different errors. So we are going to look at Python as a calculator, and we are going to try to compute some basic things, and then we are going to see how we can write equations and get the results. Okay? So what I'm going to do is, I am going to use the LibIDE, the same exact thing that you have. And as you have seen, it has two parts. The left is where you write a program and execute, whereas the right is what we call an interpreter, where you can write code one line at a time and execute directly. Okay, so we are going to do just the interpreter for now, but they are roughly the same. Whatever you write on the interpreter, you can put in a program and execute. So let us try to find the volume of Earth. Okay? So if you say, oh my God, are we going to do this kind of stuff all the time? I had to look this up, but okay. So what is the formula for the volume of a sphere? 4 over 3 pi times the radius cubed. Is that the idea? All right, so pi is 3.1415. You can only do 5 digits? RPI students? All right. The radius of Earth, as it turns out, is 6,371 kilometers. And then if I want to do cube, I can do this. So double star means power, and star just means, multiply, division, as you would expect. So what I have written is an expression involving numbers. When I press return, I will get the result of the expression. So what Python did is it evaluated this expression, returned me the result. So do we know if this result is correct? If you actually check, you will find that this is actually not correct. Now, if you know why it is not correct, don't tell us yet. We will get to that in 1 second. Okay? So let's try to kind of look at some basic. Yes? Yeah, keep it to yourself for a second. Okay. So let's look at some basic expressions, and then we'll come to this in a second. So you can write any combination of operations. And whenever you press return, it returns the result. Most of these are what you would expect, but there are a few exceptions. There are things that you may not have seen. So the first one that is interesting is 4 over 3, which is what do we expect? 1.3, right? But it is not. It is actually 1. Okay? So this is where math differs from computer science. So the point is that there are two different types of numbers in programming languages. This is true universally. So one is called an integer, which has no points after the comma. And the other one is called a float, which actually has digits after, even if it's 0.0. Okay? And they are treated very differently. So the main difference is that when you divide two integers, it will return you an integer. So it will throw away everything that is after the comma. Okay? So this is called integer division. And this is one of the basic errors that you will make. And after so many years, I'm not willing to tell you how many, that I will make. You have to remember if you're dividing integers or not. Okay? So to complement this, I also have this operator. This is called the modulo, or the remainder. So since I divide by integer, I get the integral part. The modulo operator will return me the divided, the result. So okay, this is not very interesting. But let's do 5 over 3 is 1. Whereas 5 mod 3 would be 2. Okay? So now modulo operator starts out easy, but actually gets very complicated. So let me try to explain to you, especially in Python. So whenever you have integer division, and modulo operator. One thing you would like to get is the following. You want x divided by y times y plus x modulo y to be equal to x, right? So let's try to kind of mentally go through that. So if I had 5 over 3 times 3 plus 5 modulo 3, okay? So 5 divided by 3 was 1 plus 5, the remainder was 2. So 3 plus 2 is 5, right? So I started with 5 and I got 5. And actually Python is one of the languages that satisfies this no matter whether they are x and y are positive or negative. But it may be very difficult to get used to them at first. I will show you a little bit, but we are not going to spend too much time on it. So one of the things that you will notice is that when you divide a negative number, the integer, so when you divide the positive, it truncates towards 0, right? When you divide a negative number, it actually truncates towards the negative infinity. So this will actually be -2, not -1. Okay, so this is one of the big differences. But it will satisfy the formula that I put down. So -5 modulo 3 will be then. Okay, so let's try to see if we can do this one. Then I'm going to stop this. Okay, so I had -5. So -5 divided by 3 times 3 plus x modulo y, right? So this is actually -2 because it goes towards negative infinity. So this is -6, so the modulo should be 1, right? So -6 plus 1 is going to give -5. Okay, so over time this will become more natural. No, it's never natural to me, but you know, it's not something I do very frequently. You always do the modulo of positive, modulo of negative is kind of more mathematicians' world. And if you were to actually do a modulo of a negative number, it always matches the, you know, whatever you're doing modulo of. Just remember that. It still is the same formula, but this will always be a negative number. Okay. So basically, integers are actually fairly simple. Just remember that if you have an expression where all the components are integers, then it will always return you an integer. So if no part of your expression is anything other than integer, you will get an integer. So integers range from negative infinity to positive infinity. So we have the regular operators, power operator, 2 stars, and the modulo operator. And always remember that the division is the part where you get into trouble if you forget. So an interesting thing about Python is that you can have arbitrarily large integers. This is not true in C, C++, because in other languages, integer is a very simple data type, whereas in Python, actually, it's a complex data type. You know, you can get arbitrarily large numbers in Python. This is actually better in my, this is a very large number. It actually tells you L at the end, right? So this would not have worked in any other programming language that, I'm sorry? L means that actually it started to use a different data type to store it. There's a big integer data type. So that the L means is just that using a different data type. That is just Python for you. So that is for integers. Of course, we don't always have integers. We often have floating point numbers. These are numbers that have a point after the comma. Okay. Now, if you have an equation with floating point numbers, it is going to return floating point numbers. So that's the main interesting part. But other than that, there is nothing interesting about it. Whereas something very interesting happens, that this operation that I just did very easily before, let's now try it with floats. You really cannot have extremely large floating point numbers because there is actually a fixed amount of space reserved for each number for the floating point operators, and at some point, when you hit that number, you actually cannot store the value anymore inside a float. This is not true for integers. But this is a Python thing. In other languages, this is true for both integers and floats. If you have an expression that has both an integer and a floating point, you actually end up getting a floating point result. So this is called a casting. So since there is a floating point, what Python will do is it will also take 4, convert it to a float, and then divide one float with the other. So anywhere in your expression, if you have a float, the result will be a floating point number. So let's go back to this one. Okay. And tell me if there is an error in this one. Now that you have seen this. Did you hear that? So 4 over 3 is returning what? 1. So it's like it has no effect, right? So it would be the same result if I had this, right? So is it a correct result? No, because it's like I haven't put 4 over 3. So what should I do? Right, I need to make one of the two a floating point number. It doesn't matter which, actually. It's a good question. So I can do it this way. You don't actually have to put the 0. You can do it this way, or you can do both. It doesn't matter. Now, if there's something confusing about this, is because of the way this expression is actually evaluated, right? So you have 4 over 3 and then other floats. Why the 4 over 3 is not a float? Because there are floats coming afterwards, right? So we are going to talk about how you actually evaluate this expression step by step. So hold that thought for a second. We will come back to that one. Okay? So it is important to remember if you expect the 4 over 3 to return an integer or a float, because it will actually change the result of this formula. Okay, so here I will stop and I will ask you to do, so we have fixed the formula 1, but I want you to write formula for 2 that will convert temperature 80 from Fahrenheit to Celsius. Okay? It is actually not 80 outside, but it is 88. And for those of you who just traveled from a Celsius country, this will help you to figure out how hot it is actually outside. Okay, so let's write that down. I want to convert 80 or 88 Fahrenheit, right? Fahrenheit to Celsius. So it tells me to subtract 32, then multiply by 5/9. Okay. So is this correct? Well, let's try it. Okay. So one of the important things is to get used to writing things on paper as well. So you can do it both ways because when you take exams, you're actually going to write on paper. So it's kind of a mindfulness to be able to write on paper and see. We expect that's not going to be very correct, but let's try. So I have 80 minus 32 times 5/9. Is it 6 degrees centigrade? That's like boiling temperatures, right? That's hotter than, Abu Dhabi. It's like, don't play soccer there. So what is it that I did wrong? So as it turns out, is it correct? No. What if I do this? So first subtract, then multiply by 5 divided by 9. Very different result, right? Is it still correct? Because they are both integers. Okay. If you want it to be very accurate, what is 5/9? Well, so, okay. So it's kind of confusing, right? What is the result supposed to be? Am I multiplying by 5 dividing by 9? Or am I multiplying it by 5 divided by 9? Okay, we will talk about that in a second. Now, one of the important things to remember is that there is no shame in putting parentheses. It's not like you have to write a piece of long line that will be correct without any parentheses and somehow you are better than anybody else. This is just not true. Just use parentheses. So anytime you have parentheses, whatever you write in the parentheses are executed first. The other important thing is integer division. So 5/9, if you did not want to lose the point after comma, then you need to put one of them as float. And now if I wanted to do the same thing for 88 degrees, I can do the same thing. 31 doesn't sound as bad actually from where I come from. Okay, so what if you wanted to do this computation over and over? So you want to make sure that you can do this equation for any temperature, okay? So because of that, I can basically store the value in a variable. So a variable is like a slot that has a name. So generally, a variable looks like this. So this very simple equation is actually much more complex than you think. It tells me that create a variable called f, that's going to be the name of the variable, and then put the value 80 inside that variable. If you have ever seen another programming languages, these are actually two separate steps. First, you declare a variable, then you give it a name, then you give it a value. In Python, you can do that at any point in time. So if I wanted to see what value is inside f, I can just do this. And it actually does the same thing that I did with any of the equations. It evaluated f, and it returned me the value. And the value of f was 80. Okay? So now I can write the same equation, but now using the value of f, like this. Okay, so what does this do? It takes the value of f and substitute inside the value here. Then whatever value of f was, in this case 80, it will subtract 32, multiply it by 5 divided by 9, and give me this. If I change the value of f, and then set the same, now I got a different value. So I can use the same equation, but using different values by simply having a variable f and then changing its value at any point in time. So we will be using variables all over the place. This is a very important part of programming. So good variable practice is very important, and if I actually not do it, you have to tell me that I'm actually using bad practice. So variables are very important, so you have to give them meaningful names, and you have to use them for what you name them for. Okay, so let's just to show this, even though it's kind of boring, I am going to basically use formulas for computing, let's say, the volume of a rectangular prism. Okay, so for example, let's go back to the Earth, right? So Earth radius was, I have written it somewhere, all right. So it was 6,371, okay? So you really cannot put like this. This is not a valid integer, right? So that's for formatting, but this is not going to work. So radius is this. If I wanted to compute the radius, the volume of Earth, what I wanted to do was 4/3 times pi times radius. Okay. So that should return the right result, except I get an error. So this is an error you will get all the time. What does it say? It says, I don't know what pi is, right? So we all know what it is, but the program doesn't know. Okay. Turns out pi is so important that it's possible to use it. It's defined somewhere. But right now, for the purpose of this, we are going to define it ourselves. So I'm going to define it. Okay. Now I can write this formula. And it will return me an incorrect result because I didn't do this area. Okay. So there are very simple things, but we have learned two important things. That you can define a variable by putting a value in it. If you use a variable before it is defined, then it will give you an error. The error in such a way that your program doesn't even execute. So if I did the same thing and wrote the same thing here like a program, so let's do this one. And now I'm going to find the volume. Okay. And then I'm going to print the volume. Okay. Which apparently I cannot write this formula correctly. Okay. So this is the volume. What if I did not have this? What would happen? You see, it didn't do anything. So because I actually tried to use a variable that was not defined. Let's try a different thing. How about this? What will happen now? Why this is happening? Because at the time it's executing here, right? It has executed this one first and this one second. By the time it came to this, it still did not know what pi was because pi is defined in the next line, right? So always think of the execution step by step, okay? This is kind of advanced, we will get back to that. Okay. So we can do whatever we were doing in the program, but in the other part. So I can do something like this. So this is the next thing that we are going to look at. This is called an assignment. So in this case, I am assigning radius the value 6,371. Okay? So assignment is kind of an interesting thing. Let's do this slowly. If this is too slow for you, don't worry, it's going to get fast soon. So anytime I write something like this, two things happen. First, I execute whatever is on the right-hand side. In this case, it happens to be just a number. Okay? Then I assign the result to this. It could be something like this as well. So what happens is that I compute 4 times 5, then I assign the result of that to x. If I had volume, now let's just define pi. If I have volume as 4 over 3 times pi times radius cube. So what it will do is, it's going to first compute this whole expression. It will look up what the value of pi is. If pi is not defined, it's going to give an error. It's going to look up what the value of the variable radius is. It's going to look it up and then find its value, if not give an error, and then computes the result of this and store it in a variable called volume. So this is called assignment. It looks exactly like a math formula, but it is not. A math formula can go either way, right? So you can also write 4 over 3 times pi times radius cube equals volume as the definition of volume. But as a program, this is not correct, because what it will try to do is execute this and try to assign it to this one, but that's not right, right? This is not a variable name. So the assignment always have the expression that returns a value on the right side and the result of it on the left side. And everything on the right should be a valid expression, meaning that if there are variables, variables should be defined, have a value, and it should return a valid value, and then you can assign the result to whatever the variable is on the right. This will become very important in 1 second. Okay? So if you wanted to kind of see, you can see the result. For example, if I have x equals 3, y equals 4, I can say z is equal to x plus y. That works. But I cannot say x plus y equals z. Okay? And you get kind of a stupid looking error message, but it actually has a point why that is the case. Okay, so not everything can be a variable name. Variable names are actually important. You cannot just use anything as a variable name. So first, your variable names should be meaningful to anybody who's reading your program. But at the same time, variable names are important because they should be following certain conventions. Generally, your variable names have to start with a letter. The only exception is you can have underscore. So you can have x, y. You can also have x. Okay, but you cannot have 3x. Okay, that's not a variable name. You can have any variable, any sequence of characters, any combination of underscore and numbers. This is a great password for everybody. As long as you start with a letter, you can have any combination of, underscore, number, or letter after the first letter. So things like this. Don't use these variable names. These are awful names. But you cannot. But there are certain sequence of characters you cannot use because they are keywords, and you are going to see what they are. But you cannot use this. You can see how this is actually blue. It's blue because it's actually a reserved keyword. You can actually see what the reserved keywords are. Let me remember how you did that. Okay, so these are all the words you cannot use as variable names. So like this. Okay, so let us do this exercise while I go and close the door before we go crazy. Okay, please, let's go through this, and then I'm going to solve it with you. So the point of a syntax error is that it's a program that is not going to execute because there is something wrong about it. Okay, so for example, when we had the assignment in the incorrect way, that's a syntax error. When we had a variable that was not defined, that was a syntax error. When you have an equation that is not complete, that is a syntax error. So syntax error are things that break down the program because they just do not compute. Okay? So I want you to pick in here to find if there are any syntax errors. People still don't have copy of it? Good job getting that there. Good job getting that there. All right. Let's talk about which of these are legal variable names. Okay, is import legal? No. If you don't know why, don't feel bad because it is one of the keywords that you're going to see a lot of. But it is not legal because it's a keyword. If you tried it, it would have failed. How about 56 ABC? Because starts with a number, right? No, starts with a number. ABC 56? Is it a good keyword? No, it kind of sounds stupid. How about car talk with the hyphen? No, hyphen is not allowed, right? So, no hyphen. I think I got close enough. How about car underscore talk? Yes, that's good. That is allowed. And that is a meaningful keyword. I can understand what that is. How about car talk? So space is not allowed because it will think it's two separate, keywords, right? It will think it's two variables. So space not allowed. I will leave it to you to find invalid variable names, but you have the whole semester to come up with them, so you will be fine. All right. So, any syntax error in the first line? No. Second line, which is what? R is not defined, right? So this will give an error because R is not defined. And that is a syntax error, meaning that your program will stop executing at that point. Let's assume that it didn't somehow. We go to the next line. I understand that there's kind of suspension of belief, but let's go to the next line. How about R.65? That's fine. How about this one? No, because the assignment has to be the other way, right? So, one of the things that you will find kind of more confusing is this. Suppose I have x equals 5, right? So if I print x, it will print its value. Or when you do x, it will evaluate it and return you its result. So you can actually write something like this. Okay, so mathematically this is not meaningful, right? X is never equal to x plus 5, right? Is this true? Right, because that would mean 0 is equal to 5. That's a different class. Okay, but in programming this is perfectly valid because this is an assignment. It tells you that execute the right-hand side, which means take x, which is 5, add 5 to it, then assign its value back to x, and now x is 10, right? So I can do x is x plus 3, and now x should be 13, okay? And I can continue adding stuff to x because I'm obsessive. Now this is so frequent that I'm going to shorten things. Take x, add some value, assign it back. I'm going to shorten this whole thing. Instead of x equals x plus 3, I'm actually going to write x equals plus equal 3. This is just the shorthand for x equals x plus 3. Okay? It is just that I've shortened it because it's such a common thing to do. So, so now the result is the same. It's like x equals x plus 3. And you can do this in any order. So you can also do for negative. So x minus equals 5 is going to leave x at 15, right? It was 20 before, now it will be 15. Then this is going to return. What will x be now? 5. Okay. X will be now 25. Okay. So it would not have worked if it was not in the way that I just described. Okay. So Now we come to the last part, but this is actually a very important part. We always rush through this, but I want to take it very slowly. Because how do you know what will be the result when you have a long, complicated expression? So things like 3 times 4 divided by 3 plus 4 divided by 3 minus 5 times 2 to the 4 to the 2 minus 4 divided by 5. How do we know what this will return? That's right, put parentheses. There's nothing wrong in the world. Okay? There's nothing of pride to write an expression that is not easy to read for others, because you will always work in a group. You want to make sure that everybody understands. But anyhow, there is a rule to how this is executed, and let's learn that. So there is a rule. When you have this complex sequence of operations, it will first do any of the powers. So anything that is a power, that is evaluated first. Okay, so let's look at this. So let's look at 2 to the power to the 2. Is this 2 to the power 4 to the power 2, or 2 to the power 4 to the, so is this, so there are two possibilities, right? So it's either like this, or like this. Okay. And the nice thing about programming is you can actually try. So is it like this? So when you have a power operation, the power operation goes from right to left. So you look at the rightmost power, take its value, put the result in the power of the next one. So whenever you have a long power operation, it always goes from right to left. Okay? So if I had 2 to the power like this, right? This is huge, but that's what it is. It is like this. Often you don't have these long power operations, but it's important to know. Power is the only one that goes from right to left. Everything else goes from left to right. Okay? So let's take this long one again. Okay? So we know that this one is executed first, right? So it should give you the same result with or without the parentheses. Is it the same? Yes? Okay. And we know that this is the same as this one, right? So power is first. In the power, you go from right to left. Okay. If you look at the remaining expression, multiplication and division are next. Yes? I'm sorry? L just means that it's a really big number. So it really doesn't mean anything for you practically, but what it's telling you is that since it's such a large number, Python decided to use a different data type to store it. For this class, it doesn't matter. Okay? That is just Python being awesome. Okay? Think of it like that. Okay, so next we have these multiplications and divisions, right? So those will be next. So I will have 4 divided by this, 5 divided by this, and 4 divided by 5. Okay? No, there is no preference between multiplication and division, but left to right. So the leftmost one is the first, right? In this case, it doesn't matter, but let's do this. So if I had, let's say, 8, let's do 256, that's easier to do, 8 divided by 4, right? So that is actually like this, because you do the first leftmost division, take the result, and do the next division, right? And if you wanted it to be this, then you should put parentheses. So parentheses always come first, but if you don't have parentheses, any sequence of multiplication and addition, it's going to go left to right. Okay? So this is the same as this. It goes left to right, right? So it is not this. Right? So let's summarize slowly what we learned and then add some more. So we said that I did something wrong. Now I cannot find the top of this. Let's see if I can find it. So we said that power first. Okay? Actually, before that, parentheses first. Okay? Then when you have power, it goes from right to left. So 2 to the power 3 to the power 4 is the same as 2 to the power 3 to the power 4. Okay? Then you do any multiplication and division. They are both the same precedence. Okay? And modulo is also, I think, at this point. And in this case, the precedence goes from left to right. Okay, so if you had 25 divided by 5 divided by 5, right, is the same as, right, this will give you, what will this give you? What's the result of this? 1. Whereas the result of this would actually be 25, right? Big difference. Then you have addition and subtraction. Okay? And again, left to right. Okay? So this is important because this way you know when things are going to be computed. For example, let's do this. So for example, in this case, this doesn't give you the same results as this one because 4 over 3 is done before multiplying it with pi, right? When you multiply it with pi, you actually convert it to float. It would give you a different result if you did this. Can you tell why they are not the same? So this is different than this. Did we hear that? Okay, so in this case, so let's do this slowly. In this case, I executed 4 over 3 first, took the result, multiplied that by 5, and then multiply that by radius cubed, right? Goes from left to right. Okay. And 4 over 3 is 1. Okay. So let's look at the other one. This one, I first did pi times 4, then divided by 3, then multiply that by radius cubed. So pi times 4 returns a float, right? Pi is a float. So 5 times 4 returns a float. Float divided by 3 returns a float. It's no longer integer division. So because of that, this returns you a different result. This is where it is kind of tricky that you have to know exactly how things are going to be executed, or do not use integer division if it's going to lead you to these troubles. But these two equations, they look the same, but they give totally different reasons, right? And which one is correct? The bottom one, right? There are many ways to get it correct, also many ways to get it wrong. But in both cases, the program executes and gives you a result, right? So because of that, the program is fine because it has no syntax errors, right? If the program executes, it has no syntax errors. But since it gives you an incorrect result, it still has an error, and that is what we call a semantic error. That means it's logically wrong, even though it computes syntactically correct. Have you ever seen like these English sentences that are totally correct, but they have no meaning? There's a very famous one I try to remember. This is Chomsky's basic example. This is the same point, right? It's syntactically correct program may have very incorrect results that's called semantic error. Okay, so let's see if we can do one more exercise. And then any exercise that I don't get to in class, please you make an effort to do it yourselves. And I want you to be responsible for yourselves to make sure that you actually are experimenting with all the results that we have. Okay, so what I recommend that you do, let's try to do 2 and 3, and then I will leave this one and one that we skipped over to you for later, okay? But please, on paper and pencil, do not write it down. Try to figure out what the output of this one is, because this is exactly the kind of question we ask in the first exam. I want you to become comfortable doing it on paper and pencil, okay? Let's try to do 2, figuring out what the output is, and let's try to do 3, again, finding out what the output is.